Hello. Good morning. Okay. All right. Good deal. I am live, and the reason why I'm looking over there is because that's where my second monitor is, where I will have all of the stream bits. And I forgot to start music. That's really loud. Not for you guys, but it's really loud for me. What? Okay. Sorry about there not being music on the last stream. There should be today. So we are picking up kind of where we left off last time. I wanted to work on stuff between then and now, but I didn't have the chance due to attending a wedding. So last time I kind of explained what's going on here, and we spent an hour and 20 minutes working on pulling data into our workspace. Something that I did not do was we also worked on creating a treatment plan um, because we had some awkward fourth trial for some of our stuff. So I'm going to go ahead and start the overall project timer today, and we are going to resume pulling our data into our workspace today. So I want to go ahead and restart this kernel so that we get everything fresh. We are using pandas. We are using some file paths to keep our raw data separate from our augmented data. We have 3 different kinds of trials, the same concentrations where we're run 3 different times. Here's our concentration list. So we have a total of 64 files, and we decided during the last stream that we were going to drop one of the trials, in particular this 25.2 trial. We're going to just drop because it was not run like it was supposed to be. Okay, so we're reading in our files here, and basically what just happened is I took the text files, which were the raw files that we got from the client, and changed them into CSV files. And the reason why I did that is because sometimes it's a little bit easier to work with some CSV files. Ultimately, after some exploration, I want to use Beautiful Soup to parse. And this is where we stopped at the end of last stream, was creating this loop here. So one thing to note is this section, which has column cells 1, and this section, both which has column cells 0, both do the same thing. They take the list of data that's present in those columns, and they attach it to a list called times and temps here. And I have a little bit of a test to make sure that the loop worked. We want the length of times and the length of temps to be exactly the same. Okay. More music time. I put a note in. This represents the inner loop of our big open everything all at once algorithm. And at the end of the last stream, we still need to develop the outer loop that iterates through all of the files. Okay. And that's what we'll be working on today. But I had this question of, how to incorporate trials. Should we take an average over all of the trials? Should we look at, each trial individually? And that's where I realized, we needed some special treatment for concentration 25 because it had 4 runs instead of 3. And we are going to exclude trial 25.2. So now our options for analysis are, taking an average across all of them with only 3 25 trials, and possibly looking at each concentration in the 3 trials and seeing if there's anything statistically significant between each concentration, and then looking at the concentration, moving through the concentrations, right? So we want to kind of figure that type stuff out. I know that I said I wanted this part up here. Let's pull data into workspace. I want to write data into local workspace so that cloud and time are minimized. That's great that this is here, but I might want to move it later after we've excluded this trial structure here. And maybe we should pull all of our data into our workspace, after we've figured out what's there and after we figured out a treatment plan. So I think I'm going to move these 3. I'm going to keep the beautiful soup up there, but well, you know what? So there we took all of our text files and converted them. Okay, so I need to leave that there. So this is like pull data into workspace. This is like the first step of that, right? Which is just getting our data into that usable format. So I think I want to go back into our little tracker here and pull data into workspace. I want to read so that the scope of information, I want to be able to view the data without file corruption. I think I'm going to update this in a way that is easy to access for ML purposes, i.e. in CSV files, or I want to say SQL. Okay, so I want to read it, so we can say here, we have read all of the files here. Let's see. I'm curious how I can get this. So this is called acceptance criteria, and I want to view all data without file corruption in a way that is easy. So basically, I need a count of files and data present. Okay, next page for music stuff, because it's being weird. Okay. So I want to, at the end of this cell here, print out how many files are in this raw path, which is data from the client, and how many files are in the interim path, and make sure that they match. So I'm going to actually put that here as a comment. Make sure that total files and raw path and interim path match. And that would actually consider this here done. Pull data into workspace. Oh, this is pull data down from database. I think that's what's going on. is like pulling the data down from the database is going to be a little bit different than pulling the data into the workspace. So let's go ahead and pull this over. And I want and this is pulling data down from the database. And now pulling data into the workspace is going to come after these things. Okay. So what I'm doing right now is just moving this pull data into workspace further down. Again. Why is it so loud? Let me make sure that that isn't too loud for you guys. That's pretty loud. We're gonna turn that down. Okay. I need to take this. Okay. Okay, so I want to go back here, pull data down from database. We have that solid. And then the first time that I use Beautiful Soup is later. So I'm actually going to move this down to right before I use Beautiful Soup. Okay, it's right there. Okay, cool. So I feel a little bit better about this, and I want to create treatment plan for structure of data. Hold on. So this treatment plan for present data is actually going to come after we read everything in, but we need to add another step in the process, which is going to be create treatment plan for overall structure of data. Okay, so there's a couple of different things that you can consider whenever you're, doing this type of import. And one of them is, you assume that everything that you get is going to be super clean and nice and organized, but that's rarely the case. So you need to figure out what you're going to do with that excess data. And that's kind of what we looked at here is we looked at, this concentration 25 had 4 trials instead of 3, and we weren't given any additional information other than that exact thing, right? And we got that here, except for 25 microliters, which has a 4th trial. They didn't tell us why. And so, we can go look. So we looked at trial 0, trial 1, trial 2, and trial 3. For a range, this last number is not included. So we opened up all of those files, and then we looked at, column cell 1, which is our information here, and we looked at the time, and we can see here that, these other trials, trial 0, trial 1, and trial 3, these numbers here are in degrees Celsius, and we know that approximately 20 degrees Celsius is room temperature. And so here we can see that we have, more than boiling temperatures, and we're getting close to boiling in some of these others. But in trial 2, it's literally the same number down the whole page. So it wouldn't be useful for us to include this trial 2 in our overall structure of our database. So we're going to exclude that. And here I printed the unique values in each data set. And in data set 0, there's 140 unique values. What that means is there's 140 different numbers in the data set. In trial 1, there's 183, and in trial 3, there's 140. Since the length of unique variables in trial 2 is much shorter than the other 3 trials, trial 2 should be excluded. And then we kind of looked at them on a pie chart as well, or on graphs. And here we have trial 0, and here we have trial 1, and here we have trial 2, and here we have trial 3. Trial 2 looks so much different than the others. And there's some statistics that we can go in and do to prove that trial 2 is statistically significantly different than the other trials. And that's something that we should do here. And I put, additionally, the shape of the data is much different. On a second glance, the temperatures recorded are no different than room temperature. Suspect that the analyte was not injected. So here I'm actually going to put in a note to include statistical analysis for proof of exclusion for trial 2. Okay. But today I want to work on pulling all of this, all of the data into the workspace. And so we moved this create plan for present data. I want to clean up each type of present data and structure it effectively so that future studies are smoother with less errors. So that's kind of what we're talking about here is, which structure are we going to use? Are we going to use everything right next to each other? Are we going to use a multi-array? What do we want to use? So that's going to come a little bit later. And the whole reason why I was talking about it here in this pool data into workspace is I want to pull it in a logical way that will empower me to create this treatment plan here. And so that means I need to make sure that I'm really organized whenever I'm pulling everything in. And here I want to create a treatment plan for overall structure of data. Basically, as a data scientist, I want to ensure that all data is similar enough to be pulled into a data frame in a way that makes sense, so that when machine learning is performed, associations are true associations and not biased due to poor data placement. What that means is basically I want to make sure that the number of trials is consistent across everything. Removing that entirely room temperature trial is going to make sure that there's not a bias towards lower temperatures whenever we're doing our machine learning later on. And plus, from the whole purpose of this project, which is, to look at solvent changes over concentration change, having that room temperature study is really going to throw a monkey wrench into our analytics later on. So we want to make sure that this treatment plan is effective. And so I'm going to make a new card here. We're going to call it this. And we're going to add in our verbiage. And we're going to add our labels. So this is something I didn't talk about last time. This is something that we are done doing. This is a story, and this is a data scientist part of what's going on, and this is in regards to the data. Like a misspelled performed. Cool. So I want to save that. And this is something that we worked on last time. So I'm still working on this pulling data into Workspace, and I'm just getting super organized before I do that, because we're about to have to do a lot of data associations. I want to restart. I want to run all. Okay. And here I'm just making sure that everything has run and that there's no errors. Okay, cool. We are ready to go. So as far as pulling our data into our Workspace, we have two different options. We can pull them in like this, where the trials are aligned, I guess you could say vertically. We could pull them in sequentially as well. So that's kind of what this argument is for, right? This is kind of sequential. And here we have an example of like a vertical type alignment. Personally, I tend to migrate towards this vertical alignment because it gives us another data association that I was talking about earlier that can be useful for machine learning down the line, because we have an additional association that's built in. We kind of have an additional feature that's built in based on how we have structured our data that we're reading into this machine learning model. There are arguments for doing it either way. So here, so our argument here, which I kind of already discussed, is that, let's do like a list of pros and cons. So our pros here is we have an additional feature built into future model through data association. Cons, and I know this from experience, difficult to work with multi-array for statistics. And statistics are absolutely a part of machine learning. So these are the ones that I can think of just off the top of my head. Let's look at some pros and cons here for this sequential argument. The immediate pro that I can think of is the focus of future model will be entirely on concentration, because we're looking at, average concentrations as they change, and so we're removing this idea of multiple trials, which means whatever model we select to do in the future to evaluate these different curves, that focus will be entirely on concentration. And we're trying to find some solvent interactions. So originally in this study, whenever I performed it when I was in college a long time ago, um, the whole goal was to extract the analyte or triclosan, which is an antibacterial soap. We wanted to extract that from soil to provide a way to quantify how much triclosan is actually in our environment. So a couple of facts about triclosan: it does not biodegrade, which means it does not get removed from our environment over time. It just accumulates. And it's really bad. It is an endocrine disruptor. What that means is triclosan, whenever it moves through your cell membranes and plant cell membranes and fish cell membranes, it actually can affect the activity of hormones. And this is known to cause birth defects in some fish. And we're starting to see more and more effects of this over time. Triclosan was originally introduced as a surgical scrub to be used in hospitals. And, for that purpose, I think it was pretty great. But over time, because it was so good at its job, people wanted the best of the best, right? And so it started being added to more and more antibacterial soaps that were used at home. And I think the introduction of triclosan contributed to, our current superbug problem. So the whole purpose of this original study was to find a way to extract triclosan from soil so that we could determine how much is actually present. And what I found whenever I was trying to find a good, solute, or not a solute, a solvent, a good solvent to use with triclosan, we started seeing some really weird graphs from when I was trying to develop my standards curves. And that's what this raw data is the information that went into building those weird graphs. We saw some shifts, and we saw some changes in the shape. We saw some changes in spiking. And that led me to believe that possibly instead of, extracting using an alcohol and an ether, we were potentially reacting and creating two different broken down components of triclosan, which is really interesting, but it also means it's really difficult to create a standards curve. So my goal for this project is to use machine learning to see if we can determine exactly at what concentration that reaction started happening instead of, this dissolution. So focusing entirely on concentration, we might be able to see that change and that shift a little bit easier. And that would be using this sequential setup here. The con of this is, of course, the converse, right? This removes the possibility of one removes the possibility of one trial being, or removes the impact of one trial. It's hard to explain what I'm talking about. Let's see. If we do it in sequential order and we take this average across all concentrations, then what if, this reaction that I'm hoping to see only happens sometimes, but not always? And if we average it out, then if we average out across all three concentrations, then we're removing the potential, removing the potential for one trial to be different than the others across each concentration. So basically we're introducing this idea of smoothing, and we're doing this data transformation before we even start. So before we even model, we're removing features, we're removing potential spikes. And so I'm very hesitant to move forward with this sequential data because we're removing this potential for one trial to be different. And until we can prove um, that they are no different, then I really don't want to move forward with this sequential type modeling. So I want to do this vertical type modeling. And that's going to be interesting. Basically, what that means, you know, if we were to do this sequential, another pro of just doing it sequentially is we could just read data into a list of data frames, and then we could just work with that list of data frames over and over and over again. Whereas here, this con is that we're going to have a list of lists of data frames. So we're adding this additional level because we'll have, you know, our first list will be all the zeros, and then our second list will be all the fives, and then we'll put that list into a list. And that can be difficult to work with as well. So, but I'd rather work with, you know, things that are difficult to work with versus removing information from our data set, at least at the very beginning. So, you know, with that said, we've got our list of lists. And we, just so that y'all can see them again, we have our list of trials, which is our 3 trials. And then we have our concentrations, and there's a list of concentrations. And then we have the one additional, and I do believe we already put all of these into, yeah, file names. That's great. So our full list, so we have our file names. So this is our full list that we'll be working with. I don't know how these got on there. That's weird. So I actually want to file names equals file names dot I wonder if I can pop. Okay, I cannot pop. By the way, popping is kind of like, will you, nope. Okay. Nope. Okay, cool. It pulls up the last entry. So if I have the parentheses on, then it pulls up the last entry. I think, yeah, string object has no attribute pop. Hold on, I need to recreate my file names. Here we go. And let's see. Okay, cool. That did not do what I wanted it to. So let's create our file names again. Okay. I want to drop, in particular, 25.2 has no aspect drop. Okay, cool. How about we try remove? Let's see what happens. yeah. We get an object. And recreating our file names. None. Okay, cool. What does remove do by chance? This isn't what I wanted. Okay, let's see here. Python list documentation. So whenever I need to figure out what's going on with something that I'm working with in Python, I just add the word documentation at the end so that I get this. So if I remove the first list item whose value is equal to X. Okay, cool. Remove, and pop does remove, okay. At the given position in the list and return it. If no index is specified, removes the, and returns the last item in the list. Okay, cool. So what I was worried about here, file names. Okay. Okay. Hold on. Let's restart and run all. Is that after we ran everything, this list of file names has some weird stuff at the end. It has this column sells business, which I don't want. So if I do file names dot pop, it said that it removes it. Okay, cool. So file names dot pop, file names dot pop. Okay, and that gets us to where we want to be. So I had to do that 4 times. Basically, the reason why I keep on restarting and rerunning, by the way, is because whenever I post up this notebook, I want somebody else to be able to click it and hit run all and get what they need to get, even though we're jumping around quite a bit. Okay, that's great. The next thing I want to do is look at this remove. Remove the first item on the list whose value is equal to X. Let's see if we have a dot remove example. Okay, we do not have a value. Let's see. And we want the 25.2 trial to be gone, and this is these are text values. And let's see if this gets us our clean file names that we're going to include. I see 25.2 is gone. We still have our 25.3 and we don't have anything weird at the end. Fantastic. So this is our file names that we're going to read in, right? Okay, so and now what I'm thinking is, I want to go with this more vertical type structure, which requires the 25s to all be at the same time, which means in my loop here, I'm going to have to create some special conditions for 25. Uh, so that's cool. First, let's just try to get them all read in. So let's do 4. Let's do J because we already used I. And file names. And then we want this to be our J. And this would actually read them in sequentially, right? And we don't necessarily want that. We want them to be read into our list of lists. So let's go ahead and make our list of lists right now. Let's call it, concentration list. So this is going to be like our zeros, all of our zeros, all of our ones, so on and so forth. Equals then our trials list. So this will be 0, 1, 2, 0, 1, 2, 0, 1, 2. This will be the concentration at the beginning. Okay, so I'm gonna do a range function, or a range loop. What that means is, we're going to move with every 3. I wonder here, with our new file names, I just want to check something out. For I in file names, can we int print int I? I want to see what happens. Okay. Can we do float? We can't do float. Okay, so now instead of these being text or string based, they're now floats. And now let's do this. Let's do file names float equals 0. And let's do dot append, and let's return file names float. Okay, now I wonder if I can sort. None. Okay. Sorted. Okay, back to list. I want to, what does sort do? Sorts the items in place. See sorted further explanation. Key equals none, reverse equals false. Let's see. Let's try sorted or sort. I always find it really hard to get this particular function to work. What was the argument? Key, yeah. Key equals foot lower. There's no attribute lower. Okay. Let's just try key equals float. None. What I'm trying to do is see if that 25.3 that we added, if we can get that in there. What if I make this an array? Hold on. I don't have numpy in yet. Okay. Or numpy. I just say numpy because I think it's funny. But it's actually numpy, which is like numbers for Python. And let's see if we can do array. And now let's try to sort. Cool. None. Is it sort values? Let's do numpy array sort documentation. Let's see here. Dot sort, cool. If none, array is flattened before sorting. Just the longest action. Sorting algorithm, quick sort. Cool, order. Returns sorted array. Array to be sorted. Okay. np dot sort let's see if that will if I don't turn it into an array, will it sort that? Let's see how length of file names, length of this, 63, 63. Okay. Then let's do file names float. Let's look at the 15th entry, which is 25.0. Let's look at 16. Okay, let's look at 14 to 20. So we get 20.2, 25.0, 25.1. It didn't sort it. Ah! Okay, so what I'm wanting to see is the very... I want to see that 25.3 sorted. So let's look at the last value. It's still 25.3. That's frustrating. Okay. Oh, hold on. Let's do np.sort file names float np.sort. Okay, now let's look. We have 25 point, and then it removed the 0, which I don't want to happen. Okay. But we do get the 25.3 in there, and we end with 100.2, which is good. And now, let's do for J and mp.sort file names float. Let's change these back into strings. Print str j. Let's see what we get. And we do, we have the 3 in there. Cool. Alright, I'm gonna skip this particular... I try to not do music that has words in it, and that was tripping me out. Okay, so what I'm doing now is I want a clean file names list that has everything in order. And so we're gonna do file names append string j, and we should be able to look at it there. And it has our 25.3 in there. Cool. Okay, so now we have everything in order here. And if we do this range in 3, every third one, it'll start a new list, which is kind of what I want to do, because these 3 are going to be grouped together. These 3 will be grouped together. These 3 will be grouped. Then these 3, then these 3, then these 3, then these 3. And I don't have to reference any of the actual names, so it's okay that they're a little bit different, which I'm very excited about. So now we need to move this entire loop in. So we'll get every 3, and now we need for k in range 0 to length of our file names list. Um, Basically, what this does is it means like exit the loop. Uh, Exit the loop once, stuff is done. In range 3, we want this to be we want this to be file names. Okay. Which will give us, whatever number we're on there. This needs to be in a different spot. We want this to be inside our loop. Here. Okay. So we want the trials, which is going to have our 0, 1, 2, 0, 1, 2, 0, 1, 3, right? We want that to reset every time we restart this loop here. Every time we restart this loop. Which I believe means we that's gonna do temps. This is right. This is good. That's what we want. With open. And then all of our soups are in there. Okay. So we have all of these happening to that with open, which is what we want. And then we have our trials. This is always the part that takes me the longest in this kind of type stuff whenever I'm working, is thinking about where do I need to put the specific things in the loop so that what I want to happen happens. So all of this is going to happen each time we iterate through the loop. I think I need to put it there. Here. Is that right? Is that with the with or the for? I want to put it with the for. That's where I want my trials to renew. And I want to start with it outside the loop. And then I want trials to restart with the for loop. But before that, I want to look at my conks dot append trials, and here I have my times and I have my temps, and I want to append my trials, but before then I need to look at my trials, and I don't want this to be, I do want this to be a list, but I want to, I don't want this to be a list. I want this to be data. I want data frames to end up in a list. And so I think I want this to be data frame. And then trials to do times. And for my graphing later, I want that to be time equals times. And then trials, this is going to be temperature in Celsius equal to temps. And then I want to append that data frame to the list. And then I want to empty the data frame. But I need to do that each time. So let's do this. df equals pd dot data frame. df stands for data frame, if you did not know. Let's do df, and let's do df here. And then here, let's do this still, I still want this to be a list. Okay, so I have my data frame. And it was here on this level. Okay. On level. Or does it need to be inside the loop? Needs to be inside the loop. So trials dot append df. And then we want the trials to happen outside the loop, and we want to restart the list and then go through. Okay. So let's see what happens. I feel like I also need to restart this df, yeah, right here. df equals pd dot data frame. Okay, with open file name k, no such file or directory. Oh, okay, yeah, I need to add in my plus CSV and all of that stuff. Okay. Okay, so this error is basically saying no such file directory 0.0, and that's true because all of my files have names at the end. And I want to do plus .txt, and that should fix it. And this might take a while. Okay, cool. Now let's see what, let's do length of our conks. 63. Okay, let's look at it then. Conks 0. Okay, so here's our, okay, that's our first list. So this has olive trial 0. And then if we look at this first 0, this is what I want to happen. Yes, we have an actual data frame here. And, you know, to kind of picture what's going on. So we have that. And then let's do 0, and let's do 1. Let's do dot head. Okay, great. And then our last one, 0, 2, dot head. Okay, that's fantastic. Okay, great. And we can also do dot sample, dot sample, dot sample. Let's do 5. Okay, great. Okay, that's kind of exactly what I wanted. So we have 63 data frames total. Now, let's see. Let's see here. Let's look at conks. It said 63 total, so I'm going to look at the very last one to see what's happening. So we still have 3 here. So I'm kind of curious because we shouldn't have 63, right? We should have, what's 100 divided by 5? We should only have 20 in conks total. So something funky happened somewhere. And instead we're getting all 63. Or we should have 21 total, I guess. And let's look at rows 250 to 27. Let's do 260. Let's do 10. I'm wondering if we attached the same data like 3 times, you know? Let's see here. It looks like we attached the same data 3 times. Okay. With df, we made the df. This is happening inside that loop, so we need to take this outside. Wait, no. This we want inside the loop. On the same level as this with open, though. Trials.append df. I'm glad to know that this is the structure that we want, which is where we have the 0 and it pulls up all of the concentrations for 0, and then we have the second 0 to pull up the individual ones. That's exactly what I want, because it makes iterating through stuff later on really easy. However, we have the misfortune of having attached the same data 3 times. Even across the 3 different trials, like at this time signature here, this 1.2 during the spike, we should not have the same exact constant or same exact temperatures across all three. So I need to figure out what happened. So I know that we want the data frame to append inside this loop, and we'll reset the data frame before going through the loop again. Does this need to be there? And does this need to be here so that it's inside this loop here? That is on the same level as this with open though. Let's see what happens if we leave it inside the loop. Who knows? Error list index out of range. Okay, let's see here. Let's see what happens when we pull up conx 0. We get exactly 1. That's not great. Let's do length of conx. Let's see. 189. Okay, so that's not what we want. We definitely want these outside the loop. Now, do we want these? That puts them fully outside of all of the loops. That's not what we want. So this is the structure that we definitely want. What happens if we move these N1? Let's see. 189, that's not what we want. We want these to be out. And just for giggles, yeah, that's what I thought. It just appends the last one. Just not what we want. Okay. Okay, let's collapse some of this stuff down. Okay, I don't need to see this. I don't need to see this. I have my times and I have my temps. After I get them, I put them inside my data frame. Is that what needs to happen? Do those need to come out? Let's see. 63. We end up with exactly the same ones all over again. Let's print trials. For I and trials. Let's print I dot head for I and trials. Let's see if it'll let me do this. It will, okay. Let's also print K. That should help a lot. It's not printing the K. Yeah, it did not print the K. Okay, let's do print K. Let's do that one separately then. Okay, so for 0, and then for 0, then for 0, then we have 1. Okay. So we're appending data 1, then the data twice, and then the data 3 times. Okay, so this with open K, that's with the same K. Okay. We need this trials dot append df to be there. This df here. But we need with a new K hold on. That needs to go there, that needs to go there. Okay. Let's try this again. Okay, so for 0, we're appending it twice. For 0, we're appending it 3 times. Then, okay, that's not what we want. So does that mean we need to flip these? Maybe. Let's see if the same thing happens. Oh, okay. We have 0, then we have 1, then we have 2. Okay, okay, that's good. That's good. Yeah. But our length of our concentrations is still 63. And I want it to be 20. And then this doesn't work when that happens, right? Yeah. Okay. So maybe we do... maybe we do the concentrations separately. And then we need to move that over. And we should end up with 63. Let's do length of trials. Oh. Okay, we don't want that to go back then. Okay, and then we end up with trials 0. Trials 1. Trials 2. Okay, now let's look. Okay. Yeah, this is more along the lines of what I was expecting. Okay. And then let's do print K of into workspace. So this is kind of like our progress bar, right? Oh, let's do K plus 1. Length of file names. Yeah, there we go. Or we could do, let's do this. K plus 1 divided by the file names. Wow. Round 2. Does that work? Yeah, kind of. I don't know what that's about. There should have been rounded. Does that make it better? No, that doesn't make it better. Okay, cool. Basically, that just tells us that's our little progress bar, right? And that's something that this is, this is something that can create an endpoint for backend engineering whenever they're developing. What they need to is, this amount has been, added to the model, and then later on, and it just gives it a way to update in real time. It's just to call that how many ever times, whatever that value is. So that's the beginning of that, and that's why it's a good idea to add progress bars. So we have our length of trials. Now, I still want to get this kind of type structure here. So we checked that all of our trials were, in fact, different. And we know that they are in the order. We could actually print our file names 0 and file names file names 1, and they should match up with this, which is pretty great. File names 2. So we have our concentrations of 0, which is great. So what I want to do now is that idea of that for, now that we have our data frames, we can do our insert cell below. So the next thing that I want to work on is getting these into this vertical space that we were talking about earlier. So we have all of our trials written in. Now I want them in this vertical space. So this is where I'm going to do the conx equals an empty list, and then for I in range 0 to 3, for I in 0 to 3, we want this to span the 4J and file names. I think I need to swap these around. Const dot append j. And that should append the whole data frame. And to double check that this works, I want to do length of const at the end. 189. That's not what we want. Okay, cool. That just appends it 3 times. That's not what we want. We want to start a new list every 3rd time. So we wanted to start a new list every 3rd time. And we want to append j we want that to happen inside and this isn't, we should do trials for j and trials. We want to start a new list for j and trials, we want to start a new list where we append that here. Const equals blank, and let's do actually let's do this. So we get our single concentration, and then our const list will be our list of concentrations. Oh, we could do that. J plus I. And that would get them different every time, because at first we'd be doing plus 0, then plus 1, then plus 2, then plus 3. But I still feel like at the very end, instead of ending up with 20, I'm going to end up with this 189. Let's find out. I end up with 63. Okay, so what I'm thinking about now is how do we get a list of every 3rd file name, basically. So I think I'm gonna work on that. Okay, so hold on. Let's do this. Let's go ahead and kernel restart and run all, because we just completed a major thing, which was getting all of our trials read into our notebook, and we should save that progress. Okay, so now I want to pull up my terminal, and I want to make sure, because last time I did this, it swapped what I was doing. Okay, let's get status. We have modified stuff to our notebook 1, which we have here. But before we do anything, I always forget to do this. I want to manually save to create my own manual checkpoint, because sometimes when you let it do auto, you're not capturing everything whenever you save, which was really annoying to figure out. So I'm going to check my status again. I'm going to get restore 01. Get status. I'm going to manually save. I'm going to overwrite that save. Get status. I thought I had already added something to my commit for some reason, and I have not. So whenever you hit get restore, it basically says go back to the most previous save, which I don't want to do. And so on my notebook, when it said, reload or overwrite, it's trying to reload it with the past save information, which I don't want. So I overwrote it. And now I'm going to add this file. And I'm going to check that it's been added appropriately. Now I'm going to commit this change message, and I want to, add, or rather, because what we did this time is we wrote everything into our workspace. So we have write all files into workspace. And I'm going to do IE into a list. And yeah, now I should be able to see that that's been added. It has, and my branch is ahead of the master by 1 commit, so I'm going to go ahead and push these changes up. I am not currently working with branches. I am the only person on my development team, and these are all changes that I want to be pushed into that, big overall master branch. What I should do, honestly, is for each of these sections here, I should, create a separate branch and then work on that branch until everything is done in one section, and then push that up. Oh, okay, it looks like I can only have one timer active at a time. That's really interesting. So I guess when I'm working on, like, project layout type stuff, then I'm going to want to, yeah, so I guess I'm just going to have to add all the times. That's kind of annoying, but that's all right. So we have all of our data written into our workspace, and now what I'm trying to do is just get everything, get that structure that I'm after achieved. And so I think I want to do, I want to create this step type system, which will look like the first one, it'll be the 0.0, and then I'll have the 0.1, and then I'll have the 0.2. And this will all be like one unit together. And I think I can do that with the, the file names, and then having, this J plus K type thing that I was working with earlier. that I have now deleted, where J is file names and this K is our range 0 to 3, right? And then the next unit that I have is, the 1.0, the 1.1, and then, it's not even 1, it's 5. 5.0, then the 5.1, then the 5.2 as a separate unit. And that's kind of what I want my overall structure to look like, is I have the 0, 0, 0. This needs to be marked down. No, it needs to be code. Let's do a markdown. And then I have the 5, 5, 5, and then I have the 10, 10, 10, and then I have 15, and so on and so forth, all the way down. So I have this like list of lists, and each item in each, inside the list of lists, so like this 0 will contain, the data frame. That way I can look at, in the overall list that only has the 21 items in it, I can call each item at a time and work on some statistics with it there. And this is what I want to end up with at the end, is this type of, data frame across data frame. And anytime that I need to flatten this information for any reason, because at the end I decide that it's not statistically different, then all I have to do is add like a dot average at the end of each item, and it shouldn't be terribly difficult to get those several data frames like squashed down, aggregated by average. It shouldn't be terribly difficult. At least that's my game plan right now. I have been streaming for over an hour for a while now, so I'm gonna go ahead and end this stream because it's been a while, and it's been a lot of heavy coding today, and a lot of talking about organization and trying to figure out the work that I did last time. It was kind of scattered, and it was because I needed to separate the idea of data structure versus data integrity and that kind of type stuff. So anyway, I hope that this has been useful to someone out there in the world. As always, feel free to leave any comments or questions in my comment box later. Have a great day. Bye.